Formula One finally admitted its cars became too big, too heavy, and too complicated for wheel-to-wheel racing. Veterans who remember when F1 cars were nimble racing machines and engine sounds could give you goosebumps from 3 time zones away know the drill. 2026 brings regulations that promise to fix everything with smaller dimensions, active aerodynamics, and a hybrid power unit that shifts the balance toward electricity. F1 created these problems, ignored them for years, and now claim to offer groundbreaking solutions to them. Whether F1 is actually learning from its mistakes or just creating new problems with extra steps comes down to how you read these numbers. Let's start with something that shouldn't be revolutionary but apparently is, because Formula One has finally figured out that massive cars might not be ideal for close racing. Shocking revelation, truly. 2026 brings cars that shrink significantly, with the wheelbase dropping 200 millimeters to 3,400 millimeters, width cutting 100 millimeters to 1,900, and the floor losing 150 millimeters. We're going from luxury yachts to large sedans, still not nimble, but progress nonetheless. Veterans who remember when F1 cars looked like proper racing machines will notice these dimensions are still massive, considering the legendary MP4 Forts had a wheelbase of just 2875 millimeters, which makes it over 500 millimeters shorter than what we're getting in 2026. At least we're moving towards sanity. These dimensional changes directly contribute to that massive 55% drag reduction target, and here's why that matters. Smaller cars create less aerodynamic disruption, which theoretically allows following cars to stay closer instead of driving behind what essentially feel like moving walls. The 2026 machines should create cleaner wakes, making the grid feel slightly less congested when cars are running in traffic. Minimum weight drops to 768 kilograms, a 30-kilogram reduction that marks the first significant mandated weight cut in over 2 decades and deliberately reverses the trend of ever heavier machines. This is more than trimming fat. It's F1 admitting its cars became bloated beyond recognition. That legendary MP4 Forts weighed around 540 kilograms, while current cars tip the scales at 800, making them nearly 50% heavier than the machine that won 15 out of 16 races. Over 3 decades, we've added 260 kilograms while making cars longer, wider, and more complex. And while this 30-kilogram cut moves us only from morbidly obese to merely overweight, it is genuine progress. F1's thoroughbreds need to start looking like racehorses again, not Clydesdales. Every kilogram matters exponentially in racing because lighter cars require less energy to accelerate, which makes that 8.5 megajoule energy recovery per lap more efficient and helps electrical systems work better when they're not fighting unnecessary mass. Drivers who've never experienced truly lightweight F1 cars are about to discover what they've been missing, and the combination of less weight, shorter wheelbase, and narrower dimensions should create genuinely agile machines for the first time in decades. They'll actually feel the steering inputs again. While everyone obsesses over active aero, Pirelli is quietly being asked to perform miracles with rubber and physics. Front tires lose 25 millimeters and rears lose 30, which represents a significant reduction in contact patches that anyone who understands grip will recognize as substantial changes. The 18-inch rims stay because apparently F1 learned not to change everything at once. But here's the real story. Narrower tires are absolutely needed for achieving that 55% drag reduction, since wider tires act like rotating walls that churn up air and make following cars miserable. By shrinking contact patches, F1 is trying to clean up the aerodynamic wake that's plagued close racing for decades, but the question becomes whether Pirelli can maintain grip with less rubber while teams deal with 30% less downforce. That's asking a lot from tire chemistry. For veterans, narrower tires represent a return to sanity because there's something to be said for tires requiring skill rather than providing endless grip. Remember when drivers had to modulate throttle to avoid spinning? The narrower contact patches should bring back driver skill elements that got engineered out of modern F1, though the irony is hard to miss. F1 spent years making tires wider to improve spectacle, and now they're making them narrower for the same reason, which is a perfect example of F1 chasing its own tail. We'll see if the skill versus grip balance finally lands in the right place. Active aerodynamics, the feature that has purists reaching for blood pressure medication, comes with numbers that are either brilliant or insane and possibly both. The performance delta is staggering because it enables drivers to switch between a high downforce cornering setup and a speed maximizing low drag configuration on command mid-lap. Z mode is the default high downforce setting that engages the full capacity of the front and rear wings for maximum cornering grip, while X mode instantly flattens the wings for straight line speed and creates what are essentially 2 different race cars. The front wing gets a 100 millimeter reduction with a sophisticated flap design to reduce disruption for following cars, and the rear wing's 3-element system allows complex airflow control in both modes. For those who remember when aerodynamics meant make it slippery and add wings, this feels like overcomplication. Fixed wings forced hard choices, But active aero lets teams have maximum downforce in corners and minimum drag on straights, which is technically impressive but philosophically questionable. The reliability concern is real because more moving parts mean more failures. And while a DRS failure costs straight line speed, an active aero failure in the wrong mode could cost the entire aerodynamic balance. Imagine being stuck in X mode through Monaco or Z mode on Monza's straights, and you'll understand why the radical level of drag reduction could genuinely transform racing or just make everything more complicated. The heart of the 2026 revolution is the new power unit, which shifts the emphasis to electricity in ways that have engineers already sounding alarms. Regulations mandate a near 50-50 power split between the traditional internal combustion engine and the beefed-up electric motor generator unit kinetic, while the old MGU-H, the complex system that recovered energy from exhaust heat, is gone and supposedly simplifying things. Instead, all electrical energy gets recovered through braking or generated directly by the engine, and the override system replaces DRS entirely. When within 1 second of the car ahead, a driver can deploy an electric boost that delivers full power up to a higher speed than the car in front, allowing for a decisive overtaking opportunity. The controversy? Complexity didn't disappear, it just moved to energy management. A strict 8.5 megajoule harvesting limit per lap is in place, and the core problem is simple physics because most circuits like Spa or Silverstone simply don't have enough heavy braking zones to consistently recover the required energy for a full lap. This has led to immediate talk about reducing the MGUK's maximum power output mid-race, which amounts to a tacit admission that the 50-50 split might be fundamentally flawed and could force drivers into embarrassing economy runs on straights. The 100% sustainable fuel mandate aligns F1 with automotive trends and environmental goals, though whether racing should lead environmental initiatives or provide escape from them depends on your perspective and tolerance for motorsport virtue signaling. Here's where 2026 gets genuinely exciting, because major manufacturers are returning with serious money and ambition that validates F1's hybrid future. Audi isn't just participating, they're cannonballing into the deep end by taking over Sauber and developing their own power unit, which represents massive commitment and bets their entire motorsport credibility on F1's hybrid vision. That 350 kilowatt MGUK and 8.5 megajoule energy recovery directly translates to their EV development needs, which gives them real reasons to stay. Ford's partnership with Red Bull marks their return after decades away, and rather than starting from scratch, they're leveraging Red Bull's success while showcasing hybrid engineering capabilities, bringing serious motorsport heritage and the manufacturer rivalry F1 has been missing. Cadillac enters as the 11th team, initially using Ferrari power while developing their own engine for as early as 2028, which represents GM's renewed global motorsport commitment and F1's American expansion. The two-phase approach is strategically brilliant because it allows immediate participation without massive upfront power unit investment, and these entries create 6 power unit manufacturers, the most diverse engine competition in decades. Different approaches to the 50-50 split should drive innovation and create genuine performance differences, while more suppliers means better deals and more competitive packages across the grid. For American fans, Ford and Cadillac provide genuine domestic connections beyond just drivers or races, putting American manufacturers with American engineering competing at the highest level. Manufacturer involvement also provides regulatory stability because when automotive companies invest billions in specific technical regulations, those rules become harder to change arbitrarily, though manufacturer F1 history is mixed at best. Honda has left 4 times, BMW departed after winning championships, and Toyota spent billions winning nothing. But the difference this time might be direct road car relevance since the 2026 hybrid focus changes the justification equation significantly. The uncomfortable truth? Regulations rarely deliver exactly what they promise. F1 teams employ the smartest engineers on the planet whose job is finding advantages within whatever rules exist. And the 2022 ground effect regulations were supposed to improve following and overtaking, but helped while creating new problems like porpoising. 2026 changes address real issues, cars being too heavy, too large, and too difficult to follow, and the solutions make sense on paper. Teams will optimize active aero in unimaginable ways, offset weight reduction with performance-enhancing mass, and maximize narrower tires through boundary-pushing techniques because that's what always happens. This is realism based on decades of F1 history, and the regulations will change the sport, but probably not exactly as intended. For veteran fans who remember simpler, louder, arguably purer F1, these changes bring both progress and compromise, with cars that will be more agile with potentially better racing, but also more complex and further from the mechanical purity that once defined the sport. For newer fans, 2026 means witnessing a genuine regulatory reset where you'll see team adaptation, driver adjustment, and competitive order reshuffling, and the manufacturer entries alone make 2026 worth anticipating. Audi, Ford, and Cadillac bring fresh energy and resources that should elevate competition. But will these regulations solve F1's problems? Probably not entirely. Create new ones? Almost certainly. Change the sport meaningfully? Absolutely. The 2026 season won't recreate the golden age older fans remember, nor satisfy everyone's F1 vision, but it does represent genuine evolution in a sport struggling to balance tradition with progress. Cars will be smaller, lighter, and more complex. Racing should be closer and more strategic. And the grid features new manufacturers with serious ambitions. It might not be the F1 of the past, but it could be the F1 the future demands. Is 2026 the revolution F1 needs, or just more of the usual beautiful madness? Like the video, comment below with your take on the new rules, and subscribe for more straight shooting F1 analysis.